2025 board paper of physics is just in my hand. In this video, I'm going to solve question number 6 of Icse board examination physics that took place today and question number 7. I have already uploaded question number 1, then question number 2 and 3 and question number 4 and 5 so that the video doesn't become too long. So let us now begin with question 6. If you have not watched these videos earlier, you could go back to this and then you can come back to question number 6, or you can watch solution of question 6 by itself. Not a problem. So let us look at the first subpart. Akash takes a uniform meter ruler and suspends a weight of 2 Newton at the end X and the weight of 5 Newton on the other end Y. And he then balances the ruler horizontally on a knife edge placed 70 centimeters from X. Draw the diagram of the arrangement. For the arrangement, you will have to show meter ruler, which is 0 centimeter, and the other end will be 100 centimeter. You could call this as end X and this as end Y. And from the center of gravity, you will show mgf, which could be the weight of the ruler. He suspends weight of 2 newtons at end X. So at X it is 2 Newton and 5 Newton at Y, so it will be like so. Now because of these weights, remember your fulcrum will be somewhere in the middle. The knife edge will be somewhere here. We do not know, but definitely this will give you the anti-clockwise moment and this weight will give you clockwise moment. They are saying that the knife edge is placed at 70 centimeter mark. Now this center of gravity from where the weight is acting vertically downwards will be 50 centimeter mark and the knife edge is going to be here, which is 70 centimeter mark. If this is 70 centimeter mark, then this moment is going to be this way. So you can call this as W1, you can call this as W2, and you can call this as W3, and your L1 will be equal to from 0 up to 70. That will be 70 centimeter. L2 will be from 50 up to 70, that is 20 centimeter. And L3 will be from here to here, 100 minus 70, and that will be 30 centimeter. So at equilibrium, according to the principle of moments, we will have the sum of anti-clockwise moments will be equal to the sum of clockwise moments. In anti-clockwise moments, you will have W1 L1 plus W2 L2 is equal to W3 L3. This will be 2 Newton multiplied by L1 is 70 centimeter plus M, instead of writing GF, we should make it as Newton. This should be Newton, so it's easier for us to compute, and this will be multiplied by 20 centimeter, which is equal to W3 is 5 Newton and L3 is 30 centimeter. So this will give us 140 Newton centimeter plus 20 M is equal to 5 3 is 15, so 150 Newton centimeter. So 20 M is equal to 150 minus 140, that is 10 Newton centimeter. So M will be equal to 10 upon 20. That will be 0.5 Newton. What did they ask us to find? Draw the diagram. So we drew the diagram. This is your first part. This will be for your 1 mark. And then this will be for remaining 2 marks. Calculate the weight of the ruler. So we will write the weight of the ruler is equal to 0.5 Newton, and that is our answer. Let us look at the second part. Three levers XYZ of equal lengths are shown in the diagram. So you can see this definitely looks like the load, so the effort point will be here. Which class of lever does this belong to? Your A answer would be, as the fulcrum is between the effort and the load, it will be class 1 lever. So in class 1 lever, we can have mechanical advantage either greater than or less than or equal to 1. The B part says among X, Y and Z, which one of them will give you maximum mechanical advantage? Now in case X, you can see from here to here effort arm is greater than from here to here load arm, and therefore mechanical advantage, which is the ratio of effort arm to load arm, this is going to be greater than 1. In your Y case, this effort arm is equal to load arm, so therefore mechanical advantage will be equal to 1, and in case of Z, effort arm is from here to here, effort arm is less than the load arm, and therefore mechanical advantage, which is effort arm upon load arm, this will be less than 1. So your answer for B will be therefore X. Can you see mechanical advantage is greater than 1? X has mechanical advantage greater than 1. Underline this. Greater than 1. Therefore, X gives maximum, underline that, mechanical advantage. So we justified the answer and we gave the reason in steps like this. Not a problem, you will get your marks for this. If you written the same way, write it in the comments that you got it right. Question number 6, subpart 3. Richa is at P and she comes down the slope like this on her skateboard, reaches Q, and she reaches Q at 10 centimeters per second. That's the velocity. Calculate the kinetic energy of Richa at point Q. What do we have as the data given? Question number 6, third part. The weight of Richa is 40 kgf. Immediately gives us the mass of Richa as 40 kg. And at Q, so velocity at Q is equal to 10 meter per second. Calculate the kinetic energy of Richa at Q. So kinetic energy at Q, we have the mass and we have the velocity. So half mv square would give us half into 40 into 10 into 10, that is 100. So 2 goes here 20 times, and that would give us 2000 joules as our answer A. B. The vertical height of P above the ground. So H at Q, they are asking to find. They are also giving you value of G as 10 meter per second square, and they say ignore friction. The initial potential energy will be equal to the kinetic energy at Q. So initial potential energy is at P will be equal to kinetic energy at Q. I hope you have written by law of conservation of energy. Your mgh will be equal to kinetic energy at Q, if we do not write 2000, if we write half mv square, that's also doable because mass and mass will get cancelled. This will be 10 into h is equal to half into v square. V over here is 10, so 10 into 10, and that is 100. So 2 ones and 2 50s, so h turns out to be 50 upon 10, that is 5 meter. Did you get this as the answer? Write it in the comments if you got that right. This is your answer B. This is the height at P. Part C, kinetic energy of Richa at point R. Now we do not know whether it was the maximum height attained over here, but at this point. So we know that kinetic energy at Q we calculated as 2000 joules, and the kinetic energy lost is 500 joules. So the kinetic energy at Q is the total mechanical energy at Q. Okay, here kinetic energy will be 2000, but potential energy will be 0. Now kinetic energy lost from Q to R is 500 joules. So the total energy at R should be 2000 minus 500, which is how much? 1500 joules. The total energy at R will be partially kinetic energy and partially potential energy, and that will be equal to 1500. So kinetic energy plus potential energy will be mgh2, let us say, is 1500. So kinetic energy here, mass is 40 into g is 10 into height is 3, which is 1500. So the kinetic energy is going to be equal to 1500 minus 1200. That will be 300 joules. Let me double check. At Q, whatever was at Q, that came here. So the total mechanical energy lost is 500 from Q to R. Total energy at R will be 2000 minus 500 is correct. That is 1500. So KE plus PE is 1500. And this is mgh2. This data has been given. So this is 1200. So 300. Now check back. Now let's check back. Here it is 1500 joules, and that is 1200 plus 300. So 1200 is your mgh, that is PE. So this must be kinetic energy, and that is our answer C. We come to question number 7. The first part is very simple. Draw a block and tackle system of pulleys with velocity ratio equal to 3, which means there will be 2 pulleys in the upper block and 1 pulley in the lower block. Precaution has to be taken that you show the rigid surface, you show the hook, and then you will show the first pulley with a larger diameter, second pulley with a smaller diameter, show the hook, and then you will show another pulley with a smaller diameter, and you will show the load here. From the center of gravity, you will show the load acting vertically downwards, and start with the effort. You will automatically get where you have to attach the string. Then you will show this each being the segments of the string with TTT, and then the load will be equal to 3T, effort will be equal to T, and mechanical advantage load upon effort will be 3T upon T. In ideal situation, it will be 3. So this was a fairly simple to label everything: upper block, lower block, load, effort, and the rigid surface. All that will give you your 3 full marks. Question 7, second part. A submarine in the sea sends ultrasonic ping and a stopwatch is started simultaneously. The stopwatch stops on receiving the reflected wave for the obstacle and reads 1 minute 40 seconds. So to get the reflected wave, the time is 1 minute, that is 60 seconds plus 40 seconds, which means the total time is 100 seconds. Calculate the distance of the obstacle from the submarine. Here we will use the formula for echo. Total distance will be d one way and d in the return path. So that is 2d upon t. And so your distance will be equal to v into t upon 2. That gives us velocity in the water is given as 1500. So 1500 meter per second multiplied by time, which is 100 seconds, and that upon 2. So seconds unit wise gets cancelled, and we have 15 and these 1 2 3 4 zeros, those many meters, which means you will make it into kilometers, 150 kilometers, and that would be the distance. Write the answer statement, and that is our very easy question 7. So far question 7, the first 6 marks were very good. Hope you got them right. Write in the comment box if you were able to get them all correct. The third subpart, the diagrams given below show 2 sound boxes A and B with wires of same length L. So the distance here, that is L, and the tension 10 kgf but different across sectional areas. Simultaneously, a vibrating tuning fork of frequency 300 Hz are placed on the boxes A and B, and the paper rider falls off in case of B but not in case of A. So for B, the frequency of the string is equal to frequency of the tuning fork, which is 300 Hz, because of which the resonance took place. This much segment of the string started vibrating with a larger amplitude, and this paper rider got thrown off. Name and explain the phenomenon responsible for falling off of the paper rider in B. So what is the phenomenon? The phenomenon here is resonance. And how will we explain it? As the frequency of external periodic force, that is the frequency of the fork, equaled the natural frequency of the string. It readily took the vibrations of the fork and began to vibrate with larger amplitude. I'll just continue here. Due to resonance, put a dash over here, making the paper rider fall. Okay, what are the keywords? The frequency of external periodic force, which is the fork, equaled, double underline, equaled natural frequency of the string, and so it began to vibrate with double underline larger amplitude due to double underline resonance. Okay, so that is how the paper rider fell. Let's come to B part. The wire A resonates with tuning fork of frequency F. Is F greater than or less than or equal to 300 Hz? Now this length of the string resonated with 300 Hz, and they have different cross-sectional area. So this one is a thicker wire and this one is the thinner wire. How does the frequency depend upon the area of cross-section? Inversely proportional. So the thicker wire will have frequency less. More the area of cross-section, less is the frequency. Now if this A resonates with another tuning fork, that tuning fork must have the lesser frequency because both of these are having the same length. The frequency of this is 300 Hz. So the thicker wire definitely will have less than 300, and so the tuning fork also will have less than 300. So we have to just mention it this way, that in your B part you will say A has more area of cross section, therefore has less frequency, and you will say that frequency inversely proportional to the area of cross section. So therefore if A is resonating with F, so frequency F is less than 300 Hz, and that is our answer B. So this is the fourth subpart of question 7. Now question 8 and 9. Now question 8 and 9 will be another video because this video will become too long. So I'll stop this video here, and for question 8 and 9 I will see you in the next video.